everyone, how's it going? It's Vasco from the Angular University. In this lesson, we are going to implement the unread messages counter functionality of our application. Remember, this was the initial problem that caused so many issues on Facebook. We're going to see how this functionality can be very easily implemented using the store solution. So how and where do we implement this logic? As one would expect, this logic would be implemented in the reducing function of the receive new messages action. Let's switch back to the code. So we have here the reducer function that handles the new messages received action. This is the action that is triggered whenever there are unread messages coming from the server. So what we need to do here is we need to complement this existing logic, so the current logic simply adds the new messages to the store by adding them to the messages map and by linking the thread to the message. What we also need to do is go through each thread, and if the message does not belong to the current thread, then this logic is correct. So let's switch back to the browser. So if Alice is chatting with, let's say, Bob, all the messages of each will be displayed here in the messages section. So there is no need to bump the unread messages counter because each message is continuously read. We should only increment the unread messages counter if some other user, let's say Check, sends a message, for example, to Alice. In that case, we should increment this counter to indicate to Alice that there are messages in other threads to be read. So what would this logic look like in our reducing function? It would look something like this. We are going to add an if condition based on the message thread ID. We are going to check if the thread of the message that we just received from the server, if this is identical to the current thread ID. And notice that in this reducing function, we don't have here this information available. We are going to see how to obtain it in a moment. Right now, let's finish implementing this logic just to see what it would look like. So if the thread is not the current thread, then we are going to bump the unread messages counter. And where is this information available? If we see here the definition of the thread, the main model, we can see here that this is where the list of unread messages is present per user. So the thread has a list of participants, and each participant has a number associated with it, which is the number of unread messages for that participant. So what we're going to do here is we are going to go to the store state, and we are going to retrieve the thread for the message. So message.threadID. Now here we are going to access the participants map, and again we have here all the information available via autocompletion. What we're going to do here is we are going to say that for the current user ID, for this participant, we are going to increment the number that is already there. So we are bumping the number of unread messages for the current participant, and it would be as simple as that. Now take a look, the current user ID and the current thread ID, this is not available here in this reducing function. Here we only have the stored data, meaning the data of our application, the participants, the threads, and the messages. Here what we need also is information that is available on the UI state. So how are we going to retrieve this? This information needs to come here from the new messages received action. Let's refactor this class to implement these two items that are missing. So as we could see, the payload was simply the array of unread messages. What we're going to do here is, similarly to the send new message action payload, we are going to define here a custom type. We are going to follow the same convention, and we're going to call it new messages received action payload. So we are going to create here the unread messages property, which is a message array. And this is the data that we are receiving from the backend. Now we are going to also add the current thread ID, which will be a number, and the current user ID, which will also be a number. Now we are going to use this custom type as the payload here of our constructor. So now let's switch back to the implementation of our effect. Here, instead of passing the messages, we need to pass in an object, and hitting Ctrl Space, we have here the three properties that we need to fill in. The first one is the unread messages, that we are going to populate with the messages parameter that we have here. To simplify this, we are going to rename the messages parameter to unread messages. So this populates this property automatically. Now what we need to do here is we need to pass in the two extra properties that are missing, current thread ID and current user ID. The thing is, at this point we don't have this information here available. So how can we retrieve it? Again, this information is available in the UI state. The UI state is available inside the application state, so the simplest is to apply here another with latest from and retrieve the UI state. And here at this stage we will receive not a single parameter, but we will receive a tuple. So the first element of the tuple will be the unread messages that arrived from the server, and the second element of the tuple will be the UI state. Now we have here the UI state available, so we can use it to populate the missing properties. So let's add here some formatting, and with Control Space we have here the missing properties, current thread ID and current user ID. So let's fill them in. So from the UI state we fill in the current thread ID, and now we only have one property missing, which is the current user ID. This is also available in the UI state under the property named user ID. So at this point we have filled in the payload of the new messages received action. So now this means that this is available here in the store data reducer. And also action.payload. This is no longer a list of messages, so we now have here a compilation error. So it's another great example of how TypeScript continuously helps us to write our program. In this case, what we're going to do here is we are going to take the unread messages and we're going to assign it to new messages. Now let's fill in the last couple of variables missing. So to keep this part of the program easier to read, we are going to define these local variables here. So the first one is current thread ID, which is equal to the action payload current thread ID, and the second one is the current user ID, which is equal to the action payload current user ID. So with this we have all the information necessary to correctly populate the unread messages counter. And with this we have the reducing logic implemented to handle new messages coming from the server. Let's now see this in action on the screen.